Hello, programmers! This discussion covers everything you need to know about arithmetic operators and an introduction to precedence of operations. It may even cover things you didn't want to know, but as a programmer, you need to know them. Also covered is the mod operator, which gives the remainder when performing an integer division. Here are some basic definitions. Operators are like action verbs. They are doing something to or with the operands. Operands are like nouns. They are things that get acted upon. The equal sign and the plus are binary operators. The word binary here is used to indicate that there is an operand on both sides of the operator. The word binary here is not to be confused with binary numbers, which are base 2 and only have values of 0 or 1. Although the assignment operator equals looks like the math equals sign, we need to understand that what it does is store what is on the right side into a variable that is on the left side of the assignment operator. A variable must be placed on the left side to receive data, not the other way around. X equals 7 semicolon is okay. 7 equal x semicolon will not work. If I write x equal 3, the assignment operator equals is a binary operator. It requires something on each side of the equal sign. If I write x equal minus 3, the negative sign is a unary operator, while the equal sign is a binary operator. If I write x equal 5 minus 3 semicolon, then the minus is a binary subtraction operator. The computation result is 2. If I write x equal 5 plus negative 3 semicolon, I get the same answer, 2, but this time it starts with a 5 and adds a negative 3. The plus is the binary addition operator with an operand on both sides, while the minus in front of the 3 is a unary operator which creates a negative 3. Division uses the terms dividend, divisor, and quotient. In programming, the dividend and divisor are both operands because they are being worked on by the operator, which in this case is the slash divide symbol. Let's review mixing data types. Integer data types are byte, short, int, and long. Real numbers have the float and double data types. Real numbers are also called floating point numbers. If all the data types in a math operation are integers, the result will be an integer. If all of the data types are floating point, the result will be floating point. Going from left to right, if we have a floating point value followed by an integer, the integer data type is promoted to a floating point data type during the computation, and the result is a floating point value. The integer is still an integer in memory and has not changed. X, Y, and Z are declared and initialized. Int x equal 5, int y equal 4, double z equals 3.0. Int a equals x times y. A becomes a 20. Int b equals y times z. Well, this is illegal. It is illegal to store a double into an integer because a double uses more memory and can contain digits past the decimal. Depending on how it is configured, some C or C++ compilers will only give a warning, truncate all the digits past the decimal, and store the number in the integer variable. Other settings for the C or C++ compiler will give a syntax error and not successfully compile the program. In Java, it is totally illegal to store a floating point data type into an integer, even if there are no digits past the decimal. Int c equals open parentheses, int, close parentheses, open parentheses, y times z, close parentheses, semicolon. This is okay. Y times z was cast into an integer. Here we are telling the compiler to treat y times z as an integer so that it can be stored into C. Here are some examples of implicit data type promotion. For example, an integer can be promoted to a double. It is called implicit because the compiler will do it automatically. Double A equals 5.0 times 2.0, semicolon. Both are real numbers. Double b equals 5.0 times 2, semicolon. The 2 was converted to a real. Double c equals 5 times 2.0, semicolon. The 5 was converted to a real. Int d, 5 times 2.0, semicolon. Well, we can't store a real into an integer. When the compiler itself is doing the data type conversion, it is referred to as implicit. This chart not only shows the number of bytes in each data type, their numeric range, but also which data types can be promoted to another data type. For example, an int can be promoted to a long, float, or double, but not the other way. There are a couple of other interesting things to notice in the chart. The int and long are both the same. That is because when C was first being developed, mini computers were popular and they typically organized their memory in 2 bytes, while bigger computers organized their memory in 4 bytes. A programmer could then specify whether a 2-byte or a 4-byte int was desired by specifying either the short or long data type. Now, by default, an int is 4 bytes long. 2 more things to notice is that C++ calls the Boolean data type bool, while Java calls it boolean. C and C++ have both signed and unsigned integer. Java only has signed integers. Depending on the compiler settings for C and C++, the compiler will promote an integer to a double, but will either issue a loss of precision warning or an error when converting from a double to an integer. If only a warning is issued, the program will still compile and run, but you may not get the results you were expecting. You can tell the compiler to treat one data type as though it was another data type. For example, a piece of data that is of the double data type can be temporarily treated as though it is an integer. However, the actual data type is not changed. This is called explicit data type conversion because the programmer is the one who causes the conversion, not the compiler. Casting a double to an integer causes digits past the decimal point to be truncated. They are lost instead of being rounded up. Double x equals 7.8, semicolon. Int y equals open parentheses, int close parentheses, x, semicolon. The value in y becomes 7, even when 7.99999 is converted into an integer. It becomes a 7. When you display a numeric value, it might be rounded up on the display, even though in memory it has its original value. The 7.99999 might be displayed as an 8.0 if the output is being formatted to show only one digit past the decimal, but it is really 7.99999 in memory. C++ has several ways to cast from one data type to another. There is the good old C-style cast. This works for C, C++, and Java. C++ can also use a function-style cast. C++ can also use a static underscore cast. This is really easy to spot when you're looking at the code. One important thing you need to know about each of the math operators is to make sure that you don't overflow the data type that you are using for the result. Division works differently when working with integers and floating point numbers. When dividing integers, the result is an integer quotient and an integer remainder. For example, dividing 27 by 4 gives a quotient of 6 and a remainder of 3, also called the modulo. The /divide operator produces the integer quotient, and the % modulo operator produces the remainder. It takes 2 separate operations to get the quotient and remainder. I suppose the % sign was chosen as the mod operator because it has a slash as part of its character. Some programming languages spell out mod, M-O-D, as the modulo operator. Watch out, some fonts have a funky % sign. When working with floating point numbers, the quotient is always a floating point number. For example, 27.0 divided by 4 gives a quotient of 6.75. Be careful with this one. Dividing 27 by 4 gives an integer quotient of 6 because both operands are integers. Even though the answer is stored into a variable whose data type is double, the integer value 6 is promoted to 6.0. And Q3 is a 6.0, not a 6.75. You can cast either the 27 or the 4 to a double, then the division result is in 6.75. Q3 equals open parentheses, double, close parentheses, 27 divided by 4. Remember that if one of the operands is floating point data type, then the other operand is promoted from an integer to a floating point data type during the computation. The mod operator cannot be used with real numbers in C or C++. Although the mod operator is permitted in Java, I have never found it useful. But at least Java can say it has a mod operator for floating point numbers and C++ doesn't have one. The program crashes in C or C++ when attempting to divide by 0 unless the division is placed inside of a try block, which is part of the try, throw, catch exception handling. In Java, the result is either infinity or negative infinity. Anytime you're dividing, especially when dividing by a variable, it is important to place the division inside of a try-catch block for exception handling to prevent the program from crashing. I won't cover exception handling here. The C language introduced the auto-increment and auto-decrement. The auto-increment adds 1 to a numeric value. For example, a equals 5, a++. After the statement a equals 6. This produces the same effect as a equals a plus 1. b equals 10. b minus minus. After the statement b equals 9. This produces the same effect as b equals b minus 1. The increment or decrement can be applied either at the beginning of the statement or after everything else in the statement has executed. A equals 5, int x equals plus a plus 10. A is equal to a 6 and x is equal to a 16. B equals 5. X equals b plus 10. B is a 6, but x is a 15. The variable b does not get incremented to a 6 until the rest of the statement has executed. The value of b was still a 5 when 10 was added to get a 15. The 15 is stored into x before b was incremented. The arithmetic assignment operators create a shortcut way of combining an arithmetic operator with the assignment operator. For example, a equals a plus b can be shortened to a plus equal b. I suspect the arithmetic operators were created because when a program was compiled on the PDP-11 computer, it had a similar instruction that could be used instead of 2 instructions. This would make the program run a little faster. There is an arithmetic assignment operator for each arithmetic operator. Even the %mod operator has a %equals arithmetic assignment operator. When working with calculators, you can find a different order of evaluation depending on whether it is a 4-function calculator or a scientific calculator. Evaluating 2 times 3 plus 4 times 5 is evaluated from left to right without any priority given to multiplication or division over addition. The answer for a standard 4-function calculator ends up being 50. A scientific calculator gives multiplication and division priority over addition and subtraction. 2 times 3 plus 4 times 5 evaluates the 2 times 3, which is 6, and the 4 times 5, which is 20, and then adds those values to get 26. The Calculator app on Microsoft Windows can select either mode of operation. In a math class, you may have been exposed to "Please excuse my dear Aunt Sally," or some other version, to help remember the acronym PEDMAS as the order of parentheses, exponents, multiplication, division, addition, and subtraction. Although it still sounds cool, multiplication and division have the exact same priority and are evaluated left to right. Addition and subtraction also have the same priority and are evaluated left to right. If you really like acronyms that use the first letter of each word, maybe you like MATH, which stands for mental abuse to humans. A math book may write x equal 5 open parentheses 2 plus 3 close parentheses. Multiplication is assumed when a number precedes an open parentheses. In programming, the asterisk multiplication operator is required. X equals 5 times open parentheses 2 plus 3 close parentheses semicolon. The asterisk must be placed in front of the open parentheses to cause the multiplication to happen. Parentheses, curly braces, and square brackets are used for totally different things in C, C++, and Java. Parentheses are used for two purposes. One, to control the order of operations in an expression. X equals open parentheses 5 plus 2 close parentheses times 6. 2, to supply parameters to a function, constructor, or method. A equals square root open parentheses 25.0 close parentheses. Curly braces define the beginning and end of a block of code or data. Square brackets used when defining or accessing the contents of an array. Note, Visual Basic uses parentheses for array notation. I was looking over a 5th grade math book. They were using curly braces, square brackets, and parentheses as though they were all parentheses. The different characters help find the matching pair. The editors in most IDEs can help you find a matching parentheses, curly brace, or square bracket by selecting one of the characters. The IDE will then highlight the matching set. Some languages like Visual Basic use the caret to identify an exponent. C, C++, and Java do not have an operator to calculate an exponent. The caret operator is the bitwise exclusive OR operator, not exponent. Use the power function, pow open parentheses x, y, close parentheses, method from the math library to raise x to the power of y. Here is a more complete list for precedence of evaluation. It shows angle brackets, parentheses, math operators, and the arithmetic assignment. It also shows the priority level for each operator. You may notice that this table starts at level 16 and skips many levels going down to 1. There are a lot of other operators that have not been covered yet. Another thing to notice in the table is whether the operator is processed from left to right or right to left. What about 2 divided by 3 times 5 or 5 times 2 divided by 3? Multiplication does not have a higher priority than division. They have the same priority and are evaluated left to right. 5.0 times 2.0 divided by 3.0 correctly computes to 3.333333. 2.0 divided by 3.0 times 5.0 is 3.33333, not 1.33333, because the operators are evaluated left to right. 5 times 2 divided by 3 is 3, because 5, 2, and 3 are integers. 10 divided by 3, the quotient is 3. The remainder of 1 is not used. 2 divided by 3 times 5 is 0, because 2 divided by 3 is evaluated first. The quotient is a 0 and then multiplied by 5. Looking at the floating point evaluation again, 2.0 divided by 3.0 times 5.0 is 3.33333, not 0. In math, the commutative property states that the answer will be the same when you move things around. For example, 2 plus 3 gives the same answer as 3 plus 2. 2 times 3 gives the same answer as 3 times 2. Let's see if it always works this way when we write a program, especially when working with integer. Now, let's look at how we convert a temperature expressed in Celsius to Fahrenheit. They don't share a common 0 point. Fahrenheit came first. Daniel Fahrenheit chose 0 to be the point at which a solution of salt water froze. 212 degrees just happened to be the number that showed up on his thermometer when water boiled. Celsius belongs to the metric system and is named after Anders Celsius. 0 degrees is where plain water freezes at sea level, and 100 degrees is where water boils at sea level. Most countries in the world use the metric system. The freezing point is offset by 32 degrees between Fahrenheit and Celsius. The range between freezing and boiling is 100 degrees Celsius and 180 degrees Fahrenheit. The formulas are C equals open parentheses F minus 32 times 5 divided by 9. F equals C times 9 over 5 plus 32. Although you can easily look up the formulas for converting between Celsius and Fahrenheit, you should understand how the formula is derived. A similar exercise may be required when taking numbers in a table and trying to determine the position they would be placed on a chart on a computer screen. You would need to compute the location of pixels on the screen by determining the range of numbers, the range of pixels used on the screen, and the offsets for starting value of the numbers and starting pixel positions on the screen. Using all integers and setting the value 78 for Fahrenheit, the result is 25 degrees Celsius. 78 minus 32 is 46. Multiplied by 5 is 230. An integer divided by 9 gives an integer quotient of 25. The cout statement is for C++. The printf statement is for C. The %d in the format specifier string indicates that an integer is to be displayed. System.out.printf can be used for Java. Watch out for this one. According to the math laws of commutation, it should not matter if we put the multiplication of 5 divided by 9 before or after the parentheses for open parentheses f minus 32, close parentheses. But since 5 and 9 are both integers, the quotient of dividing 5 by 9 is 0. It is the quotient that is being used. Therefore, we get 0 times 78 minus 32, and temp Celsius ends up being a 0, regardless of the value for temp Fahrenheit. We can fix this by either using a floating point value for at least one of the numbers, 5 or 9, or we could even cast one of the numbers, 5 or 9, to a double. Then we can get the correct answer, 25.55556, regardless of whether 5.0 divided by 9.0 is multiplied before or after the parentheses. I hope you found this presentation informative, even if it seemed to violate some of the rules of mathematics. As programmers, it is not our option to agree or disagree with how the innards of a computer work, but to understand how it works and write programs to make it do what we want it to do. I'll see you around. Until then, bye.